So in this video, we will learn something really beautiful. It's known as the trigonometric form of the Ceva's theorem. So if you do not know what these things mean, don't worry. I will explain everything. The Ceva's theorem is a very powerful tool in the Math Olympiad geometry course. You can learn more about this course in the link in the description. Also, I will be asking a question at the end of this video. There are awards for the best comment over a period of 1 month. So make sure to watch the entire video. Let's get started. So, what is the main question? And this was asked by one of the students of Chinta in our WhatsApp groups. It says that suppose you have a triangle ABC, any triangle, and you draw a perpendicular from A to BC. Suppose this is X. So AX is perpendicular to BC. And you draw two more lines, BY and CZ. All three of these lines will pass through the same point, this particular point. So this is a single point of intersection. And it's not given that these are perpendicular. So this can be any line segment. So what we have to show is that this AX bisects angle ZXY. ZXY, this angle. Okay, so we will be using Ceva's theorem, a trigonometric form of the Ceva's theorem in some sense, to figure this out. So this is the claim. Now, what is a Cevian? A Cevian is a segment from a vertex of the triangle to a point on opposite side. So this is an example of a Cevian, AX. Now the Ceva's theorem says, and this is a very powerful theorem, Ceva's theorem says that if three Cevians pass through a single point, just like it does in this particular picture, they pass through a single point, then we will have bx over xc. So I think of it like this, bx over xc times xcy over ya, cy over ya times az over zb. This product, so you see, I have traveled along the sides of the triangle in a cyclic manner. This product is 1. This is the result of the Ceva's theorem, conclusion of the Ceva's theorem. This happens, when does this happen? Only when the Cevians are concurrent. Concurrent means they pass through the same point. They pass through a single point, just like it did in our problem. So we will be using Ceva's theorem here, but we will first talk about a certain trigonometric formula for the area of the triangle. So this is the trig formula, for area of a triangle. So if you have a triangle, let's say PQR, and if this angle is theta, the angle in between QP and RP is theta, then area of this triangle is half times QP into RP into sine of the angle theta. Remember that this sine theta is sine of the included angle. So you take product of two sides, product of these two sides, length of these two sides, and sine of the included angle. Half of that is the area of this triangle. So here is a challenge question. The challenge question 1. Can you prove this? Prove this area formula. And there is a bonus challenge. There is a bonus challenge. Is there a similar formula for a rhombus? So if you can find it, then you can put it in the comment section. All right. There will be more challenges in this particular video. So keep on listening. So we have these two pieces, the Shiva's theorem and the trigonometric formula of area. Now we are ready to apply these ideas. The only way to learn problem solving is by applying the ideas and theorems that you learn in the class. We follow this principle in our Math Olympiad programs as well. Hence, we have so many problem solving classes every week. If you are an internal student of Chinta, I strongly recommend that you attend all the problem solving classes. Those who have done it before, they have done really well. So let's come back to this picture. So we have this situation. Now suppose this angle is theta 1, then this is 90 minus theta 1, and suppose this is theta 2, so this is 90 minus theta 2. We want to show, our goal is theta 1 equal to theta 2, right? We want to show that these two angles are actually equal. So what I'm going to do is, I'm going to compute AZ over BZ. AZ over BZ. Now notice that it is equal to the ratio of areas of these two triangles, right? So this is equal to ratio of areas of AZX and BZX. This is a very powerful little tool. I call it the little area ratio tool. It's very effective. That if you want to find out ratios of two triangles, areas of two triangles, it's basically equal to the ratio of their bases, because the height cancels off. Both of them have the same height because they have the same vertex and the bases are on the same straight line. So this is AZ by BZ, but now we can use the trigonometric area formula, which is AX times ZX times sine theta 1 divided by BZ BX times ZX times sine of 90 minus theta 1, right? Because this angle is 90 minus theta 1. Half, to multiply half. So half and half will cancel off. Zx and Zx will cancel off. So we have Ax over Bx sine theta 1 divided by sine of 90 minus theta 1 is cos theta 1, right? So Az by Bz is, so this is the final thing, Az by Bz is Bz is Ax by Bx into sine theta 1 by cos theta 1, right? So similarly, I can find out Cy times Ay. Cy times Ay. Cy times Ay will be Cx divided by Ax into cos theta 2 by sine theta 2. So this is the challenge 2. Can you show this calculation in the comment? Yeah. All right. So now we'll be using Ceva's theorem. Basically, let's multiply these two pieces. So if you multiply these two pieces, you will get Az by Bz times Cy by Ay is equal to Ax by Bx times Cx by Ax times tan theta 1 by tan theta 2. So Ax and Ax will cancel off, and I can just cross multiply these two. So I have Az over Bz times Cy over Ay times Bx over Cx is equal to tan theta 1 divided by tan theta 2. I'm in the final step. This thing is by Ceva's theorem 1. So you can check with this diagram. It will be exactly equal to 1. So this is 1. So tan theta 1 is equal to tan theta 2 is equal to 1, which means tan of theta 1 is equal to tan of theta 2. This is the last step, and I want the reason in the comment section again. This is challenge 3. I've asked 2 more questions before. Challenge 3 is, why does this line imply that theta 1 equal to theta 2? Why is that true? So can you show this in the comment section? Why is tan theta 1 equal to tan theta 2 mean? Why does it mean that theta 1 equals to theta 2? All of these are very subtle points, and as a student of mathematics, you should be very careful about the subtleties of geometry problems. I hope you learned something. You learned how to use the trigonometric form of the area formula along with Ceva's theorem. Actually, there is a different formula which is known as the trig form of Ceva's theorem. It's a bit different from what we did today. What we used here is the trigonometric form of the area formula inside the Ceva's theorem. So that's a bit different. Maybe I'll talk about the trigonometric form of Ceva's theorem in some other video. I hope you liked it. If you want to know more about Chinta's online programs, outstanding Math Olympiad, ISI, CMI entrance, physics, informatics Olympiad programs, then please check the link in the description. Keep on doing good mathematics, and I'll see you in the next one.